Good afternoon, all. I am Sheetal Nagar, faculty of B.Tech EC Department, IIMT Group of Colleges, Greater Noida. Today, I'm going to give a little information regarding the topic that is logical instructions of 8085 microprocessor. In the previous lectures, I have covered the instruction set of 8085 microprocessor, and in this section we will cover our next group, that is logical instructions of 8085 microprocessor. In 8085 microprocessor, we have different groups. Like first one is data transfer group, second one is arithmetical group, and next one is logical group. In this section, we will complete this logical group instructions of 8085 microprocessor. First of all, an instruction is a binary pattern which is designed inside a microprocessor to perform a specific function. The entire group of instructions that a microprocessor supports is called instruction set. In 8085 microprocessor, we have 246 instructions. Each instruction is represented by an 8-bit binary value. That is a hexadecimal code, which is the representation of the instruction, means this instruction what will perform, what will be executed in our microprocessor. These 8 bits of binary value is called opcode or instruction byte. The whole instruction code, which is 8-bit only, this one is called instruction byte. Now, as we discussed classification of instruction set, first one was our data transfer group, next one was arithmetic group, next one is branching group, control group, and logical group. Today we will focus on logical group. In logical group instructions, this group contains logical instructions, means those instructions who will perform the logical operations like AND operation, OR operation, XOR operation, and rotate operation, compare, and complement. These all operations covered under this group, logical instructions group. First one is AND, OR, XOR. These all instructions are depends with which one register we are communicating. Any 8-bit data or the content of register or memory location can logically have AND operation, OR operation, XOR operation with the contents of accumulator, and the result of the operation will be stored in the accumulator only. Means if we have to perform AND operation, we have required 2 contents. First data or content will be in any general purpose register, like 8085 microprocessor have 6 general purpose registers: register B, register C, register D, register E, H, and L. These are general purpose registers of 8085 microprocessor. If we are taking 2 data, first one number must be in the accumulator, any one number, any one content will be saved in the accumulator only, and then another one we will take in any general purpose register. After the logical operation, the result will be stored in accumulator only. Accumulator and all general purpose registers in 8085 microprocessor of 8-bit only. Now, rotate operation. Each bit in the accumulator can be shifted either left or right to the next position. This operation will be performed with the help of rotate instructions. In this group, we have 4 instruction to rotate the contents of accumulator in left side and in right side position. Okay, with the help of rotate instruction, we can rotate the contents of accumulator through carry also. The two instruction for simple rotation and two instructions for the with the help of carry rotation. We have four instructions in rotate group. Now next one is compare. Okay, now in compare instruction, any 8-bit data or the contents of register or memory location can be compared for equality, greater than, less than with the contents of accumulator. The result is reflected in status flags only. In compare instruction, we compare the contents of accumulator with the contents of any general purpose register, but after the execution of this instruction, nothing change will be happen in accumulator. After compare instruction, we don't any change in the contents of accumulator. The contents of accumulator will be same, but due to the result of compare, flagged registers will be affected. Now next one are complement instructions. As we all know, if we want to complement the bits of accumulator, if we require the complement of the contents of accumulator, as in 8085 microprocessor, we have 8-bit accumulator, and with the help of complement instruction, we can each bit of the accumulator will be each will be replaced by 1, and each 1 is replaced by 0. Now logical instruction compare. First instruction which we are going to discuss, that is CMP. Operand is R or M. Now what will be happen after execution of this instruction? CMPR. First case for the compare instruction we will take, that is CMPR, means compare the contents of, R means any general purpose register. For example, which general purpose registers we have in 8085? B, C, D, E, H and L. So we can compare the contents of any general purpose register with the help of compare instruction with the contents of accumulator. The contents of the operand are compared with the contents of the accumulator. Both contents are preserved, means no change in the content of general purpose register and in the contents of accumulator also. The result of the comparison is shown by setting the flags of flag registers are as follows. Okay, if we compare the contents of accumulator and register R, for example, we take the register B. For example, we use instruction that is CMPB. So with the help of this comparison instruction, the contents of accumulator and the contents of register B will be compared internally, means a subtraction process will be performed internally in 8085 microprocessor, but for the programmer, for the users, only this flag registers will be set or reset as per the contents of accumulator and the general purpose register. In the first case, for example, if the contents of accumulator is less than the contents of register or memory, M represent here that memory. Later we will discuss what is this M. Okay, if the contents of accumulator is less than the contents of register and the contents of memory also, then carry flag is set and 0 flag will be reset. Okay, if we have less contents, so the number of contents of accumulator is smaller than the contents of register, then carry flag will be set. For example, if we have in accumulator that is 03 and in the general purpose register B 04, after CMPB instruction, the carry flag will be set and the contents of accumulator and register B will be same. Means no change after compare instruction in any register, only carry flag will be set. Now next case, if the contents of accumulator and the contents of general purpose register are equal, if both the contents are same, then zero flag will be set. Means if we take if we take 04 in accumulator and 04 in register B, and after that we execute compare B instruction, if we have both the contents are same, then after execution of this instruction, zero flag will be set, because internally a subtraction will be performed, that is the contents of accumulator minus the contents of register B. And if we see in the subtraction process, the result will be 0. Hence, zero flag will be set after execution of CMPB instruction if the contents of both the registers, accumulator and general purpose registers, are same. Now, the next case is if the contents of accumulator is greater than the contents of general purpose register B or memory location, then carry flag will be reset and zero flag also reset. Means if we have contents in accumulator that is 04 and in the register B that is 03, and after that if I execute the instruction CMPB, then both the flags, carry flags and zero flag, both flag will be reset. Means no one flag will be set. But after compare instruction, no change in the contents of accumulator and register B. Now, what is this M? First of all, we have to discuss what is this M. CMPM, compare M. What is the meaning of this instruction? If we take this instruction CMPM, the meaning of this instruction is that compare the contents of accumulator with the contents of memory location, which is pointed by the contents of HL register pair, which is a memory pointer. For example, if in a register pair HL we have 8041 content, then contents of memory location 8041, that it may be anything 8-bit data, it will be compared with the contents of accumulator. Means M is a memory pointer which is specified by the contents of HL register pair. This is represented by M, and the meaning, simple meaning of M is memory pointer. Now, CPI, compare immediately. The last one instruction was CMP, compare. Now next compare instruction is CPI 8-bit data. Means in this case, the contents of accumulator and the operand content, that is any 8-bit data, will be compared immediately with the contents of accumulator. In this case, the 8-bit data is compared with the contents of accumulator. The values being compared remained unchanged. Same process will be applied here. After CPI instruction, there are no change in the contents of accumulator, and only flag register will be affected as per the last discussion, as in same as in compare instruction. But the only change is that in this instruction we compare immediate 8-bit data immediately with the contents of accumulator. Again same, if the contents of accumulator is less than the data, then carry flag will be set. If the contents of accumulator and data will be equal, then zero flag will be set. If accumulator contents are greater than data, then carry and zero flag are reset. Both will be reset. For example, we can take any 8-bit data, CPI 89H. Now, next logical instruction we are going to discuss, that is ANA, R or M. M again, we are talking about the 8-bit data. It may be in any general purpose register or it may be at any memory location. If you are talking about the memory location, we will represent this 8-bit data by M. But the memory location will be specified by the contents of register pair H and L. Means with the help of two registers, we can point up a memory location, because the combination of two registers in 8085 microprocessor, it can contain 16 bits also. Single register, single general purpose register will contain 8 bit, and if we have three register pairs in 8085 microprocessor, register B, C, register D, E, register H and L. M memory pointer is HL register pair. Means if we have to point up any memory location, we have to store this content in HL register pair. Okay. Now, ANA instruction is used for logical AND operation. Means if we want to end operation with the contents of accumulator and the contents of any general purpose register or memory location, then after AND operation, the result will be stored in accumulator. Means if we talk about any instruction, any arithmetical and logical instruction, after any arithmetical and logical operations, our accumulator contents will be changed. Means after execution of any instruction, the result will be stored in accumulator also. Means with the help of accumulator, we perform any arithmetic and logical operation, and after the execution of the instruction, result will be saved in accumulator only. Now, A and A are the contents of accumulator are logically ANDed with the contents of register or memory also. The result is stored in accumulator also. If the operand is a memory location, its address is specified by the contents of HL pair, as we already discussed. Sign, zero and parity are modified to reflect the result of the operation. Means after execution of this instruction, sign, zero and parity flag will be reflected, modified. It will be modified also. So carry is reset and auxiliary carry is set in this case also. For example, we can take any general purpose register. In this case, we have taken A and A, B. Means the contents of register B and the contents of accumulator will be logically ANDed, and the result will be saved in accumulator also. In the next case, in the next example, that is A and AM. In this case, the contents of accumulator and the contents of memory pointer, which is specified by the contents of HL register pair, will be ANDed, and the result will be stored in accumulator only. Now, next one instruction is ANI 8-bit. Means logical, in this operation, 8-bit immediately and ended with the contents of accumulator also. With the help of ANI instruction, we can immediately end operation with this 8-bit data, and the result will be stored in accumulator only. For example, ANI 86H. Here, this H is represented, this 86 is in hexadecimal number. ANI, and immediately 86 with the contents of accumulator, and the result will be stored in accumulator only. Sign, zero, and parity flag are modified to reflect the result. As per the result, they will be modified. Carry will be reset and auxiliary carry will be set for this logical instruction. Now, next one is XRAR. XOR operation will be performed with the contents of register R and the contents of accumulator, and result will be stored in accumulator also. This instruction is used for XOR operation, and again it will be the same. R represent any journal purpose register and M is the memory pointer also. With the help of this instruction, only sign, zero, and parity flag will be modified, and carry and auxiliary carry will be reset. For example, XRA B. With the help of this instruction, the contents of register B and the contents of accumulator will be XORed, logically perform XOR operation, and the result will be stored in accumulator only. ORA, R, and M. ORA instruction is used to perform logically OR operation with the contents of journal purpose register and the contents of accumulator also. ORA, for example, if we take ORAB, then the contents of accumulator and the contents of register B will perform OR operation, and the result will be stored in accumulator only. With after execution of this instruction, flag register sign flag register bit 0 and parity will be modified. Carry and auxiliary carry flag will be reset. Now, ORI, or immediately, means with the help of this instruction, we will perform logically OR operation immediately. 8-bit data with the contents of accumulator, and result will be stored in accumulator only. For example, ORI 86 means 86H 86. The 8-bit data will be OR operation, logical OR operation with the contents of accumulator. It may be anything, and the result of the OR operation will be stored in the accumulator only. After execution of this instruction, in the same manner, sign, zero, and parity flag will be modified, and carry and auxiliary carry flags are reset. Now, next one is XRAR. With the help of this instruction, logically XOR operation will be performed with the contents of any journal purpose register and the contents of accumulator, and result will be stored in the accumulator only. For example, XRAB, after execution of this instruction, the contents of register B and the contents of accumulator will perform XOR operation, and result will be stored in accumulator only. After execution of this instruction, sign, 0 and parity flags will be modified to reflect the result of the operation. Carry and auxiliary carry flags will be reset. Again, next, for immediate operation, XOR immediate operation, we have another instruction, that is XRI 8-bit data. After execution of this instruction, 8-bit data immediately will perform XOR operation with the contents of accumulator. After execution of this instruction, after sign flag, 0 flag, and parity flag will be modified to reflect the result, and carry flag and auxiliary carry flag will be reset. Now next one is our rotate instruction, that is RRC. In RRC, we use this instruction to rotate the contents of accumulator in the right direction. Each binary bit of the accumulator is rotated right by one position. Bit D0 is placed in the position of bit D7 as well as in the carry flag also. Carry flag is modified according to bit D0. Sign 0 parity auxiliary carry are not affected with the help of this instruction. For example, RRC. RRC is a 1 byte instruction, as in front of RRC there are no any operand, no any journal purpose register, no any 8-bit data, no any 16-bit data, and this instruction is a 1 byte instruction. RAL, rotate accumulator left through carry. Each bit of accumulator is rotated left by one position through the carry flag. Bit D7 is placed in the carry flag and the carry flag is placed in the least significant position D0. Carry is modified according to bit D7, sign 0, parity, and auxiliary carry flag will not be affected with this RAL instruction. RAL instruction, all rotate instructions are of 1 byte instructions only. Now next one is RAR, rotate accumulator right through carry. Each binary bit of the accumulator is rotated right by one position through the carry flag. Bit D0 is placed in the carry flag and the carry flag is placed in the most significant position D7. Carry is modified according to bit D0, sign 0, parity, and auxiliary carry are not affected after the execution of RAR instruction. Now, next one is logical instruction, CMA. This instruction is used to complement the contents of accumulator. For example, if we have any content, if we have all the 8-bit 0 in accumulator, after execution of CMA instruction, the contents of accumulator will be 8 times 1. Means all the zeros will be complemented or converted into 1 after execution of CMA instruction. And no flags are affected after execution of this instruction. Now CMC, complement the carry only. Okay, if we have to complement the carry flag only, we have a instruction, logical instruction, that is CMC. The carry flag is complemented, no other flags are affected by this instruction. For example, CMC, both CMA and CMC, both instructions are of 1 byte only. Now, next one is STC, set carry. To set the carry flag, what is the meaning of this set? Set means we have to make our carry flag 1. We have to make the contents of carry flag 1. Means for this operation, we have an instruction that STC. After execution of this instruction, the contents of carry flag will be 1. No other flags will be affected after execution of STC instruction. Now the summary of logical group. This group perform logical operations on data in registers and memory and on condition of flags. These instructions enable you to set specific bits in the accumulator on or off. for example, ANA, ANI, ORA, OR, XRA, XRI, CMP, CPI, RLC, RRC, RAL, RAR, and these complement instructions CMA, CMC, STC, and R. Okay. Thank you very much.